Hi, welcome to the Shiko Math Lab differential equation problem solving session. So today, I'm going to solve this differential equations, and it's x cubed y force dx plus y cubed dy equal to 0 with the initial value y0 equal to 1. So in fact, today, when I try to solve this differential equation, I will solve this differential equation by using two different methods here. So as you can see, when we try to solve the differential equation, there are not only one method, could have two or three different methods you can use. I like to use this one to demo because this will be a simple one, so it will not make the video too long. So I like to use this differential equation to demo. I can use two different methods here. And in fact, one of the methods is very simple, and then the other one is a little bit more complicated. And that's why I would recommend a student typical before you start. So it's always examine the problems and to see which will be the easy one you can use here. All right. All right. So now let's go ahead and start. Okay. So I want to solve this one. Okay. Method number one. See here. Okay, so let's see here. So here, like I say, I typically like to put the dy dx together. So this is y. So this is y cube and dy dx here. Okay, so dy dx equal to 0. Okay, so now I see this one's here is a y and y. It's kind of like by itself multiply. So I think that could be a very good candidate for the separations, variable separations, right? Okay, so the first thing is here, I will divide by y the cube both sides. So I will make a dy dx stand out by itself. So this is dy dx is equal to x, okay? So dy dx, okay, be careful about the algebra, plus x3 y equal 0, right? Then I can move the x cubed y to the other side. So dy dx will be equal to the negative x cubed y. As you can see, the x and the y, they are separate. So will be a good candidate for the variable separation. So I can solve it. So I said the dy over y, right? Move the y to one side and the x on the other side. So x cubed and the dx. Now integrating both sides here, right? So like we say, okay, now we integrating both sides, and then this is good. So this will be a natural log y, okay, is equal to negative x the fourth and over 4. Wow, good. Okay, then let's take a look at my initial condition, y0 equal to 1. So then plus c's, right? So now I can put a y0 equal to 1 to see what is my c values here. All right, so that means the natural log 1 is equal to negative 4, 0 to the fourth power plus c. Then this is 0, right? So what I have, c is equal to 0. So I got my answers here. So it's a natural log y equal to the negative 4x fourth. Now I take the exponential both sides. So my final answer is y equal to the negative x fourth over 4. Right, so this will be my solution. This is my first method, by the variables separations, right? As you can see, it's very simple. The the differential equations and you can solve it just like how many steps? 1, 2, 3, 4, 5. Five equation, we can solve it. Okay, so now I'm going to show you how to do by the other methods here, just in case your teacher want this methods here. So this is the one we use the exact differential equations here, all right? Okay, so now, just like we did a while ago, I changed this to the x3, y4, right, plus y3 dy dx equal to 0. All right, so for the exact differential equation, so this is one of my function, and let's do here, this is another of my function here. All right, so this function I called is mxy, so this is mxy, and this is nxy. All right, so this is the step number 1, right? So then the number 2 is here. Okay, so this is the step number 1. So assign each function. Then step number 2 is here. I'm taking the derivative of partial derivative of mxy. I take a y here. So if you take the derivative for y, this will give you what? 4x cubed y cubed. All right. Okay. Now I also take the derivative for nxy instead of take the partial derivative for x, so it's a y. So nxy is y cubed, but if you take the derivative to x here, what happens here will be 0. Oh, wow, unfortunately, this 2 is not equals, right? So if this 2 is not equals here, so we cannot apply right now we cannot apply exact differential equations here. So now our next step, because they are not equal, so what I need to do, I need to find the integration factor. Okay, so the integration factor, if you still remember, it will be du dx. Then the top ones here going to be m partial derivative y minus partial derivative of x, right? Then divided by nxy. Okay, so times u. Right, so my goal is to try to solve u. So in here, then the my is 4x cubed y cubed minus 0. Nx is what? Is y cubed times u. All right. Okay, so here I should say equals, right? Okay. Okay, then this one will be equal to, so the y cube cancel that out. So this will be what? 4x cubed times y times u, right? Now, I can move the u to the left-hand side. This is number 4. Okay, so I will say u. So I will say du over u is equal to 4x cubed over dx here. All right, now I will integrate both sides. I will get a ln u is equal to x to the 4th. So now I will have u is equal to the e to the x for the 4th. Okay, so now let me highlight the equations here, right? So I'm going to substitute this one we just find here. I will just find u is equal to e to the x to the 4th. I'm going to, just like we did for the integration factor, I'm going to substitute to my original. I'm going to multiply this by my originals here. All right, so now let's see what do we have. So this is number 5, step number 5. So I times it. So this will be e to the x fourth, then x3, y4 plus e x fourth y3 dy dx equal to 0. So now for this equation, so this is my new mxy here, and this one's here will be my new nxy here. Okay, so now, let's go ahead here. Be very careful. So this is my step number 6. So my new mxy is equal to the e to the x fourth, x to the cube, right? X to the cube, y fourth. Right, then nxy is the pink one. So that's new nxy is e to the x fourth y to the cube. Now I'm going to do the partial derivative for the y's here. Okay, so when I do the partial derivative for the y, x is a constant. So this is y to the fourth, right? So this will be 4y cube e to the x fourth x cube. All right. Then this one here, I need to do the partial derivative for x. So if a partial derivative for x, y is a constant. So the ex force will be itself, right? Ex force exponential. Then times the chain rule. So it's 4x cube. Then still have y cube. Then now you compare these two. Well, excellent. These two is equal, right? So y cube, x cube, x cube, and so it's great. So I know I finally changed this equation to a homogeneous differential equations with exact different, the exact, the differential equations, right? Because the my equal to the nx. Okay, now because they are exactly the same, we can apply our regular methods here. So what is the first method? I assigned this 5x functions, right? So 5x function going to be my mxy. Remember, everybody still remember that the methodology. So this will be e to the x fourth, x cube, y fourth. All right. And then I'm going to have assign my y function equal to the nxy. All right. So the nxy is going to be e the x fourth y cube. All right. So now this one I'm going to integrate, okay, with respect to x, right? With respect to x. Okay, so this respect to x, so give me 5xy. So the x is in here. You can use like a u sub and do a chain rule. So I assume everybody know how to do this integration, right? So this will be equal to, okay, so this will be equal to the 4e to the x to the fourth. And y is a constant, so it's here, y fourth. Then plus hy. Okay, so here you do a little u sub, right? For this, so you say u is equal to x fourth then du equal to 4x3 dx. That's how do you get this integration. Okay, so now from here, I take the derivative, a partial derivative for the y's here. That means I'm taking the derivative for the y. So y, x is a constant. So the first term is y fourth. So I take a derivative will be 4y cubed e the x fourth over 4 plus h prime y. Cool? All right, so now here 4 and 4 is cancel, right? So this one will give me e to the x fourth y cube plus h prime y. So, okay, so now remember, okay, so here, now this number, because they are both is the phi function, the partial derivative to y, so it's equal to this, right? So they are equal, right? So because they are equal, so what that tell me? So that means e the x force y3. So this is step number 8. Okay, equal to e the x force y3 plus h prime y. So what's that mean? That means h prime y equal to 0, right? So if s prime y equal to 0, that means if you integrate, so hy equal to some constants c here. Correct? Okay, this is to some constants c. Then you substitute this ones here, right? So this ones here, okay, so I was, so we'll see here, right? So here you put it back to this equation, we just, so hy is some constants here, right? So now what I will get here, I will get is e to the x force, y force, to the 4 equal to the c constant. Now you can times the c both sides, so you can ex force, y force, some c stars, right? So now you substitute your y0 equal to 1, your initial things here. So y0, so this will be e to the 0 to the 4th times 1 to the 4th equal to c star. So that's why C star equal to what? C star equal to 1. Okay, great. So finally, we be able to find my equations here. So I will have E the x force, y force is equal to 1, correct? So then I will find it. So y force is equal to 1 over e the x force. So it's e to the negative x force. So y will just be equal to e the negative x force times the force roots. So that's why I give you e the negative x force over 4. Ha! All right, finally we solve this. This will be our final answers here. All right, so this will be my final answers here. Okay. Okay, so here, let me see here. This will be my final answer. Okay. So y equal to negative 4. So if you compare to the answer from my first methods here, hey, they match here, right? So they match here. Hey, it's exactly match here, right? So you know you can use different methods to do it, but just as I show you by comparing the method number 1 by variable separation, very simple. Then if you are accidentally, you did not think about the variable separation, then you start to use the exact differential equation, integration factor, it will be a long process, right? But you will get the same solutions here. All right, that's it for this problem. I just want to introduce you. When you try to do the differential equation, look at the problem first and try to do the easiest one you could. All right, so that's why I always say in my video, the YouTube video. If the method I solved, you see some other method is easier than my method, and feel free to let me know because I would like to learn some of the other methods if I can use and it'll be easier. All right, that's it. And that's for today. And I hope that you enjoyed watching this and have a good day. And I will talk to you next time for some other differential equation. All right, bye. Enjoyed it. Okay, bye bye. Have a good time.